Welcome students, welcome to the present class, that is class 7th. Topic is lines and angles. Today we will be talking about this lines and angles. Before talking about this lines and angles, we should know that what the present topic is about. So the present topic comes under the jurisdiction of geometry, that is the branch of mathematical that we deals with the shapes, their measurement and so on. So the basics of this geometry is point. Point is dimensionless, that is it does not have any length or breadth. Once we have something that has length, that is called a line. So line is having the length but not the breadth. Length has the property that it extends in both the directions infinitely, and this line is made by joining these points, which we call as dimensionless. They don't have the length, they don't have the breadth, but this line has the length and it extends in both the directions. Now if I limit the length in one direction, then it becomes a ray. So ray is which is fixed at one end and extending infinitely on the other end. And further modification of it is line segment. Line segment is when we have fixed it at both the ends. If the line is fixed at both the ends, then it's called a line segment. In fact, line segment itself says that I am the segment of the line, that is I am not the full line, I am just the part of it. So if I draw a line here, let this be the line, and if there is 2 points, say A, B, we can clearly see that the 2 points A and B restrict the present line segment. So the line segment has the property that it has 2 end points, right? So we start with a point that is dimensionless, and when we join the points, that makes a line, and when we fix it line at one end, it becomes a ray, and when we limit it at both the ends, fix it both the ends, then it becomes the line segment. One thing that must be noted here, that it is not always that line may be straight. If the line is straight, then it's called a straight line, but it is not always that line could be straight. Sometimes it could be curved too. In fact, we say that line is made by the points. So if the points are joined in such a way that it forms the curved line, it is possible. Yes, it is clearly possible that the line can be curved too. If the line is straight, that it forms a 180-degree angle, then it's a straight line. So moving further, we will have what the angle is. Remember students, we are learning lines and angles, that is why we are talking about lines and angles right now. So what the angle is? Angle is nothing but the orientation between two lines or two surfaces. So we say orientation between two lines or two surfaces. If both the surfaces lie in the same direction, that means the angle is 0. If the surfaces lie at the orientation of 90 degree, that is it is right angle, and if the surfaces lie apart, opposite to one another, then it's a straight line or a straight angle. So making all of them, so if this is one surface and it is other surface just lying above it, making a 0-degree angle. And other example, and the third example, we can clearly see that from example 1 they make a 0-degree angle, because both are oriented, both the rays lie in the same direction, they point towards the same direction, that is 0-degree angle. Now here the one ray points towards, suppose this is east, and other ray points towards north, that is it makes a 90-degree angle. And third time, third example, we have one ray that is pointing towards east and other ray that is pointing towards west, that is they are directionally opposite to each other. So that is why they are called as, that is this is 180-degree angle and they form a straight line. Okay. What we call the angle which is less than 90, that is called acute angle. Suppose there is an angle which is less than 90, let it be, suppose it is 30-degree. So this angle is called acute angle. So if an angle is less than 90, it is called an acute angle. If an angle is greater than 90, let us suppose it is 120. If the angle is greater than 90, this is called obtuse angle. So this is acute angle and this is obtuse angle. What if the angle is exactly 90? That is called as right angle. Suppose this is A, this is B, this is 90-degree. So for which angle in isolation, but pair of angles. So the first that comes in this category is complementary angles. Complementary angles are the angles whose sum is 90-degree. So when we have two angles, let this be suppose 60-degree and let this be 30-degree. If I add both the angles, the sum is 90-degree. Okay, let us say that this is 1, this is 2. So angle 1 plus angle 2 means angle 60 plus 30, that is 90. We say that, why I named it? Because for the purpose. So we say if the two angles sums up to the 90, we say that they are complementary angles, and angle 1 is said to be complement of angle 2 and vice versa, that is angle 2 is complement of angle 1. One thing that must not be confused here, that these angles need not to be separate, they can be at one place too, like this one. Let this be 40, that be 50, that is they are together, but still their sum forms 90 degree, their sum equals 90 degree, that is 40 plus 50. So, this again is the example of complementary angles. Got it? Next, in this category, on the similar patterns of the complementary angles, we have supplementary angles. So, supplementary angles are those angles whose sum is equal to 180. Sum equals 180. So, here we say sum equals 90. Now, if I say sum equals 180, that is they are supplementary angles. Again, let us take the example. Suppose we have an angle like this and let it be 110, and we have another angle, let it be like this and it is 70, and their sum, if we add the both the angles, angle 1 and angle 2, their sum equals 180. 110 plus 70 is 180. So, if the sum sums up to, if the angle sum equals 180, then it is, they are called as supplementary angles. Again, I want to remind you that we are talking about the related angles, that is one angle, how one angle is related to another. So, pair of angles, if their sum is 90, that is complementary angles. Pair of angles, if their sum is 180, then it is supplementary angles. Again, like we talked about the complementary angles, that they can be joined to at a one place. Similarly, we can have here, like let it be, it is 50 degree and another angle is 130 degree. They are at one place, they are joined together, but their sum is equal to 180. Still they form the supplementary angles. So, in short, till now we talked about complementary angles sum equal to 90 and supplementary angles sum equal to 180. I hope you got it until now. Next in the category we have adjacent angles. Before going into what the adjacent angles are, we need to understand what the adjacent mean. Adjacent mean next to something, simple words, next to something. To understand what this adjacent next to something mean, let me take an example. Suppose we have 4 students sitting across the table, and it is roll number 1, roll number 2, roll number 3, roll number 4. Let us understand what the adjacent mean by this example. So, we have 2 students sitting on the other side of the table, one side of the table, and roll number 3 and roll number 4 sitting on the other side of the table. We can clearly see that 1 is neighbor of 2, that is 1 is adjacent of 2. Similarly, 3 is adjacent of 4, or 4 is adjacent of 3, vice versa. But 1 and 3 are opposite to each other. 1 and 3 are opposite, similarly 2 and 4 are opposite too, sitting opposite to each other, but 1 and 2 are adjacent and 3 and 4 are adjacent too, right. So, we got it what the adjacent mean till now, but we will be talking about adjacent angle, what the adjacent angle is. So, for adjacent angle we have some criteria. We have 3 criteria rather. First criteria is common vertex. They should have the common vertex. Second thing is that they should have common arm. And third thing is that they should not have common interior point. So, we can write no common interior point. I will talk about it, what this common interior point is. So you have to remember these three conditions, that they should have the common vertex, they should have the common arm, and they should have no common interior point, right? Let us take an example to understand what it actually is. You see that there is angle 1 and angle 2. We take an example, let it be A, B, C, not necessarily, but still we name it. If we see angle 1 and angle 2, they share a common vertex. Let this common vertex be O. They share adjacent angle, they should have common vertex. Yes, they share a common vertex, that is vertex O. That is, this condition is fulfilled. Second condition is that they should have the common arm. Yes, they have the common arm like this one. They share the common arm B. B is the common arm for both the angles, angle 1 and angle 2. Third thing is that they should have no common interior point. That is, angle 2 does not share any part of angle 1 and angle 1 does not share any part of angle 2. To make it more understandable, let us take the another example to make understand what this no common interior point mean. Let this be angle 1 again, let this be angle 2 again, bigger angle, and let this be angle 3 whole part. We can clearly see that angle 3 is a right angle, forming completely by the angle 1 and angle 2. That is, angle 1 and angle 2 are complement, and angle 3 is 90 degree. Now, can we say that angle 1 and angle 3 are adjacent angles? No, we can't say that. Why we can't say that? See, they have angle 1 and angle 3 have common vertex O. Yes, they have the common vertex O, clear. Second, do they have any common arm? Let us suppose that for the sake of argument, yes, they have this common arm too. But what about the common interior point? No, because angle 3 has the part of angle 1 in its territory, or angle 1 is itself a part of angle 3. That is, angle 3 has the common interior points of angle 1, or angle 1 forms the interior part of the angle 3. That is why we can't say that these are adjacent angles. I hope you understood what the adjacent angle is and what are these common vertices, common arm and common interior point. Furthermore, more example on it. Let us take this example. Let this be angle 1, this be angle 2. Here we can see that angle 1 does not form any part of the angle 2. Similarly, angle 2 does not form any part of the angle 1. That is, this condition is fulfilled, no common interior point. And they have the common arm, this one. That is, this is satisfied too, but they don't share the common vertex point. They don't share, you can see that it is vertex is this one, it is vertex is this one. So it is must condition that all the conditions should be fulfilled. So this condition, this example does not fulfill this condition of the common vertex. So I hope you understood what I mean. Next in our topic is linear pair. So we will be talking about what the linear pair is. So let me write first. With non-common sides as opposite rays. So the first thing that is necessary for the linear pair is that it should be adjacent angles. That is, that angles we are talking about should be adjacent first. So we can say that all adjacent angles, all linear pair angles are also adjacent angles too, right? So the initial condition for linear pair is that they should be adjacent angles. The next condition is that non-common sides as opposite rays. That is, we will understand by example, that is their non-common sides is that they should be opposite rays. Let us suppose this is angle 1, this is angle 2. Now can we say that angle 1 and angle 2 are adjacent? Yes, we can say that. Why? Because they have the common vertex. They have the common vertex is this one. Second is they have the common arm. So both the conditions are fulfilled. Third condition is also fulfilled, that is they don't have any common interior points. So until it is adjacent angles. Now look at this non-common part. This is non-common part, this is non-common part. The condition for linear pair is that non-common part must be opposite rays. That is, they must be oriented, apart from each other. If these are two rays, so they must be like this. They are facing away from each other, forming an angle of 180 degree. So linear pairs form the 180 degree, and what we call as 180 degree angle as supplementary angles. So we can say that linear pair angles are also supplementary angles, that is they form the 180 degree angle. We can clearly say that angle 1 plus angle 2 is here 180 degree if they form the linear pair. Let us understand it by other examples too. Non-common sides as opposite rays Let us suppose there we have an angle, there we have one ray, another ray is oriented like this, and they have the common vertex, angle 1, angle 2. Can we say that angle 1 and angle 2 form the linear pair here? No, not at all. Why? Because we already told that this ray should be at an orientation of 180 degree to each other. That is, they must form 180 degree. You can see that the ray should have been in this direction, which is not. Hence, this does not form a linear pair. Okay, I hope you got it. So apart from having the adjacent angle, that is their non-common parts, their non-common sides must be opposite rays, right? Next in this category is vertically opposite angles. Vertically opposite angles are formed when the lines cross each other, right? Vertically opposite angles when lines cross. So we can say that if this is angle 1, we make here the 4 angles, 2 lines cross each other. So vertically opposite angle is angle 1 and angle 2, and similarly angle 3 and angle 4. Why this is called vertically opposite angle? Because of sharing a common vertex. They are across across the vertex. The 2 angles are formed across the 2 sides of the vertex. That's why this is called vertically opposite angles. And vertically opposite angles 1 and 2 and 3 and 4. Let me sum up here what we studied so far. We started with the basic concept of the geometry, that is point, which is dimensionless, no length and no breadth. Then we went to the length, that is that line that is having the length only, but the problem with the line is that it extends infinitely in both the ends. So if we limit line on one side, that is called a ray, and if we limit line on the both the sides, this is called a line segment. Further, we talked about the angle. Angle is nothing but how the lines or surfaces are oriented to each other, right? Then we talked about the right angle that is 90 degree, acute angle which is less than 90 degree, obtuse angle that is greater than 90 degree, and finally we talked about the related angles, that is complementary angles whose sum is equal to 90 degree, and if the sum of two angles is 180, that is supplementary angles. And if we have the angles, they share common vertex, they share the common arm and do not form the common interior point, that is adjacent angles. And the linear pair is that adjacent angles and plus they should form this straight line, that is opposite angles should be oriented away from each other. Finally we talked about the vertically opposite angles, that is they are formed when lines cross each other. So thank you very much for listening so keenly. See you next time. Thank you.